My name is Hal Lack. This is my first video lecture and we'll be discussing pseudocode and flowcharts. Before you begin development work, i.e. coding, it's a good idea to pre-plan and organize your thoughts. And two things that can help you do this are pseudocode and program flowcharts. Flowcharts are basically from the top of the page to the bottom, and with shapes indicating various functions, and between these shapes there are arrows to indicate the direction of the program flows. I have here a number of shapes. The first one is an oval indicating the beginning or the end of a program. The next shape is a parallelogram, and it is a point where there is input to or output from the program. So for example, here we have two entry that could be made by the user, price and sales tax. A rectangle, on the other hand, indicates an assignment of a value to a variable, constant, or parameter. Here we will be assigning costs after we compute the price multiplied by the sales tax. So we can in fact include the computation inside of the box here. A diamond indicates a point where a decision is made. So for example, in here we have sales tax is greater than, if sales tax is greater than 13%, then we can make a decision based on the logic in our program. An open-ended rectangle contains comments, statements. So for example, this is a comment. The dotted line here would point towards the program flow to support. This is basically extra documentation supporting your code or your flow charts. A hexagon indicates the beginning of a repetition. So here we have a do, the word just do, and in our first example you see how this is used. The double-lined rectangle indicates the use of an algorithm specified outside of the program, for example a subroutine, or in our case, because we're using Java, it would be a method. The circles can be used to combine flow lines. So for example, from a previous page, if you're on a previous page and your flow ends there and you're running out of space and you want to continue the flow, you can continue on the other page by indicating like this, for example. So if A ends from the previous page, you can continue from the next page and just indicate with A and then the arrows continuing. Arrows indicate the direction and order of execution. So this is what, obviously we also have an example up there as well. Now here I've actually created a very simple trivial example to demonstrate pseudocode and flowcharts. So this problem is basically a simple adder that accumulates the first positive integer called start until the last positive integer end. And we'll just assume it will be inclusive. So we also assume that start will be less than n when the program first begins. The accumulated value is going to be stored in total. So for our pseudocode, we have two inputs. Two integers, start and end, and one output integer called total. So when we start our program, we enter start and end. So this could be two integer values entered by the user. And we also have a variable called total that we'll set to 0. And then once this is done, we repeat. Basically, this is a loop. So if start is less than or equal to n, continue the repetition. Otherwise, we terminate the loop, or we exit the repetition. So if start is less than or equal to n, we increment start by 1, and then we add start to total. We continue until this condition is false, and we terminate the loop, and then we come out and we print the total. All right, so our flowcharts would look like this for that corresponding pseudocode. So here we have the beginning of the program, and the parallelogram indicates that we're going to make an input into the program, so the start and end. And then after that we assign total to 0, and then we begin our loop. So when we start the loop, if start is less than or equal to n, if that is true, we would continue and increment start by 1, add start to total, and then come back up again. So if start is greater than n, we would actually exit the loop, and then we just display the total. And then the program terminates. Okay. Now this is another example that I want to show on how to use subroutines. The rectangle with the double side. So assuming that this is the start of our program, right? We want to calculate the widget cost. Now, when we flow through here, we're going to call a method or a subroutine, and it's going to be called get labor and materials. All right. So this will actually go to another method or another subroutine, which is represented by this right here, get labor and materials. And in this subroutine or method, we also again call another method, so get labor cost, and it returns, and then we can get material costs as well. And as you notice here at the end, instead of ending the subroutine or the method, we actually return the values that we got. So we're going to return the value, labor cost and material cost, to get labor and materials from here, which was the program that made the initial calls. So once we have these two values, we're going to call calculate net cost. So calculate net cost starts over here on the right hand side, and here we're going to assume that we're going to call yet another method called calculate manufacturing cost, and it will return a value which we'll make use of down here. So you can see this the assignment box down here, manufacturing cost. But once we get that, we're going to yet call another method or subroutine, all right, called calculate government incentives. So as a comment here, I put here as tax cuts for environmentally friendly processes, right? So so this can be a deduction. Oh, this is my typo here. The add sign there should actually be a negative sign. So net cost is actually equal to manufacturing cost minus green deductions. I'll have to go back and correct this. So once we have this, the value, the net cost value, it returns this value, and then it gets displayed, and then we terminate our program. Okay, so this is so in this video lecture we covered flowchart, at least the shapes that we're going to be using in this course. All right, so we have it here. So these shapes here, and I also gave an example, a very simple example of how to write the pseudocode. For example, here for this very simple example, corresponding to its flowchart diagram right here. And then for our second example, I went into a little bit more detail and covered how to use subroutine shapes that represent subroutine. So this is a little bit more complex example here, and again, this is my error. This should be a negative, but it doesn't really prevent us from seeing how the logic can be flowed. Okay, so thank you for listening, and I'll see everyone in class.